Yo kids, this is the 2019 A2 Unit 4 paper. This is the mechanics section at the back. Obviously I'm not doing stats. Question 6. This is a bit of Newton's second law and integrating and differentiating some vectors to get acceleration and displacement. It's worth 9 marks. It's not too difficult, so we should be looking to nail this question. They give us the mass and they give us the velocity vector in terms of I and j components, and they want an expression for force, right? So you've got to think, right, force is mass times acceleration. They've given us the mass. How do I get acceleration from that velocity? And of course acceleration is the rate of change of velocity. So you differentiate velocity to get acceleration. Differentiate this, the 3 comes out as a multiplier, and cos differentiates to minus sine. So that becomes minus 36 sine 3t in the I component. Differentiate this, the 2 comes out as a multiplier, sine differentiates to cos, 2 5s are 10, so that's minus 10 cos 2t in the j component. That's the acceleration. They want to know the force. So the force is acceleration times the mass. The mass, they told us, is a half. So multiply both of these numbers by a half. That gives you the force. Minus 18 sine 3ti minus 5 cos 2tj. Right, nothing too tricky on that. Given a t equals 0, so initially p has this position vector relative to the origin, find an expression for the position vector at a general time of t. Okay, so we are now going to integrate velocity to get distance or displacement. When we integrate it, we'll have a plus c on the end because it's not a definite integral. We can then sub in t equals 0 and use this to work out what that c is, and then tidy it all up to get that position vector for the general time of t. Okay, so this is how we do it. So I've used the letter s for displacement or distance, and that's the integral of velocity with respect to time. Don't forget, now when you're integrating, these coefficients of t would come out reciprocated. So that would come out as a third and that would come out as a half, right? So if I integrate this, a third of 12 is 4, cos integrates to sine, so it becomes 4 sine 3ti. This comes out as a half, so just leave it as 5 over 2. Minus sine integrates to sine integrates to minus cos, so the minus minus makes it a plus. So this becomes 5 over 2 cos 2tj plus this constant of integration c. Now they tell us that the t equals 0. This distance here from the origin is 4i plus 7j. Now when t equals 0, 3 noughts are 0, and the sign of 0 is 0, so that will disappear. When t is 0, 2 zeros are 0, the cos of 0 is 1, so it's just 5 over 2j. So I've got 5 over 2j plus this constant c equals this position vector that they told us, 4i plus 7j. If you just tidy that up, take the 5 2 over, that gives us that c is 4i plus, that becomes a minus 2.5 over there, so 7 take away 2.5 is 4.5, or leave it as 9 over 2. So that's the value of c. Now you need to put that back up here now and tidy it up so I get all the i's together and I get all the j's together. So my position vector at any time t will be 4 sine 3t plus this 4 in the I component, plus 5 over 2 cos 2t plus this 9 over 2 in the j component. Right, so that's quite juicy but doable. Again, it was just integrating, putting in t equals 0 and getting that value for c. And then the final question, hence, which means use what you've just done in part B, get the distance then at time t equals pi over 2. So whatever you've got for this, even if you got it wrong, as long as you substitute pi over 2 in for these values of t and calculate that bit correctly, you're going to get the follow through marks. So just swap that letter t for pi over 2, swap that letter t for pi over 2, and then physically work it out, and you can get an answer. So let's go through that. So 3 pi over 2, chuck that in the calculator. Sine of that is -1, so that becomes -4 plus 4, which is 0 in the I direction. Chuck 2 times pi over 2 is just cos of pi. Again, that's -1. So that becomes -5 over 2 plus 9 over 2, which is effectively 4 over 2, which is 2. So my position from the origin is 0 to the right, or to the left as well, and 2 units up. If this wasn't a 0, I would have to square, add and root these numbers to get the magnitude of that distance, but the distance is 2 units in the j direction. Okay, so not a bad question. You had to differentiate to get a, you had to integrate to get distance, you had to put in t equals 0 to find the constant of integration, and then chuck in pi over 2 at the end to get a final answer. Hope you can do it. Cheers.